Just a little bit of background first on sort of the new virtual instruments. So many of you, or all of you, are familiar with VI. This is actually the first time that I'm speaking to many of you. I've spoken to Chris on a few occasions, but that was with a Load Dynamics hat. So I come from the Load Dynamics side of the family, and back on April 4th, we merged and with VI to expand both our product lines, our customer reach, and quite frankly, to create a new powerhouse in workload analytics. So we're headquartered in San Jose, California, despite the accent. We've roughly got about 450 customers today, and a good portion of the Fortune 100. What you'll hear from us over the next hour is really an introduction into a key new cloud service that we introduced called Workload Central, and we'll talk more about that, as well as the side of the family that you won't be familiar with, which is, or some of you won't be familiar with, which is Load Dynamics. So how many people were familiar with Load Dynamics, just a matter of interest, before? So roughly half the room. Load Dynamics was founded about the same time as VI, so around 2008, and it was founded to provide storage load testing tools primarily for the vendor market. Over the last 4 or 5 years, we moved from the vendor market, where Load Dynamics has been very successful as the leader in converged file block and object storage testing, into the enterprise. And being able to model workloads, validate storage, technology, product choices for the enterprise to ensure that they're making the best decisions in terms of architecture and product, optimizing for service levels in production, as well as managing life cycle items such as change. So in how the merger came about was an opportunity last year when VI went for a round of funding, October of last year. It came to the attention of the investment group that's backing, or was backing Load Dynamics. And Load Dynamics for some time have been aware of VI. Aside from the fact that we're actually almost right next to each other in San Jose. We've got a number of shared employees from past lives who've worked at both companies, but more importantly, we had a number of key customers, people like PayPal, T-Mobile, who had been telling us for some time that we needed to work together. And Load Dynamics was moving out of the lab into production. We released something called the Workload Sensor and Workload Analytics at the end of last year to analyze storage workloads in production. And what we discovered was, in reality, there's about 95% of the same sort of capabilities on the VI side. So it just made perfect sense to bring the technologies together, and we'll talk a little bit more about how that came about. So as a result of bringing the companies together, we've got just some fabulous logos across every major vertical out there. The Load Dynamics side was more heavily focused on storage vendors. Just about every storage vendor under the planet is a customer of Load Dynamics, and VI brought a very strong enterprise customer base. In terms of the relevance across the organization, I think the key thing that we saw was the virtual instrument side of the family had a real strength in the storage engineering and storage operations space, and with an increasing penetration of the application space. The Load Dynamics side was very much focused on architecture and DevOps, because it was all about bringing new infrastructure into production. And also increasingly doing modeling around sort of new applications before those applications existed, all the cobras out there so that we can start to provision and optimize the infrastructure for the sorts of workloads being envisioned. So our value proposition really centers around understanding what workloads are. That's really the secret sauce. And it goes beyond just looking at latency and throughput. It's understanding all the characteristics down to the data characteristics of a particular workload. You know, how dedupliable or compressible is it? And being able to use that workload across the life cycle. So one of the things that we've seen consistently over a period of time is validation and testing of different kinds that had very little realism associated with them. And in that, they were either about sort of testing the maximum load that something could bear, but really didn't help you design or place the workloads across your production infrastructure. So that's been a real focus of both virtual instruments and load dynamics. And now we bring that together into really what will become a closed loop capability. So for those of you who are familiar with virtual instruments, which I think is everyone, we have both the hardware and software probes. You know, virtual instruments has been best in breed in terms of fiber channel SAN monitoring, and we've been expanding our software probes across the virtualized real estate and fabrics for some time. But what the company was known for was really having the best in-class data in the industry. And with the current generation of product, we went from having the best data to having the best answers. So providing a set of analytics that targeted specific problems like analysing queue depth, looking for slow drain issues, and being able to expose those in a very simple way up to the user through a web-based interface. So being able to correlate, do seasonal analysis in terms of trends and other things. The load dynamic side really was best in class in terms of workload characterization and modeling. And the piece in the center, which is what we'll be talking about today, is Workload Central. This is a cloud service that we've launched that is a free cloud service that allows pretty much anyone to take existing data sets, whether it's from Virtual Wisdom or whether it's from one of their pre-existing arrays in production or one of their management tools, analyze the characteristics of those workloads, be able to visualize those characteristics, but then at a push of a button be able to generate one or more workloads from that. So being able to understand how those workloads use the infrastructure and what they look like for a range of different validation. Now the load dynamics side has a tech at the core of the product is very similar to Virtual Wisdom. There is a management console and then there's a set of probes. On the load dynamics side, there's a load generation appliance and there's a test management analytics platform we call Load Dynamics Enterprise. And the first step for us that we launched at the time we announced the merger on the 4th of April was the ability to take data from Virtual Wisdom and import it directly into the Load Dynamics Enterprise so that you could capture your workloads in production and replay them in the lab to do validation and testing. The great thing about the way workload modeling is done is it's really a set of statistical metadata about the workload. So we're not doing packet capture and replay. What we're doing is building up a statistical model of the behavior. And that allows us to be able to scale that behavior. So we can, if we wanted to scale the workload to see what would happen if we increased the users or the number of servers, for example, by a factor of 10. We could stretch it, pull it up. What happens if we were to change the block size configurations or some of those sorts of things. So all that sort of what-if scenarios can be done very easily within Load Dynamics. You've got full control over the behavior right down to where you're writing the data to the LUN so that you can simulate sort of hotspots and drifting workloads over time. So a very powerful set of capabilities. And really what our customers are using us for today is to optimize their storage investments, really protect their performance and availability, and accelerate their time to resolution while providing enough bandwidth to innovate with confidence. So that's just sort of a quick recap. Before we'll jump into the demo, we'll start with Workload Central. But before we jump into the demo, are there any questions or anything I can answer around the merger or the two companies and how they've come together? I will say that we're ecstatic with the progress that we've made. We're well ahead of our plan, both in terms of merger and the business performance. It's been tremendously well received by customers, and we're seeing the business accelerate as a result of that. Okay, well, if there aren't any questions, we'll jump into the demo. So Workload Central is a cloud service that we launched at EMC World last month. We're treating it as a beta because we're actively innovating on it on a weekly basis, introducing new capabilities. But the concept around Workload Central grew out of one of the conversations that we'd been having with the industry for a while, and that is, where can I go to get my workload? You know, where can I go and get an Oracle workload? Where can I get an Exchange? Where can I get an SAP? Things that customers were really struggling to understand, and so were the vendors. I've been with the combined company now for almost 2 years, and the first couple of conversations I had with the likes of NetApp and EMC in the first 2 weeks on the job was, could you give us application workloads for a range of different applications? And it was surprising to me at the time when I said to them, well, don't you have tens of thousands of customers? Don't you know what those workloads were? And what I discovered was two things. One, they didn't have a good way to characterize or model the workload, and that's something that Load Dynamics had spent the last 5 years developing. And they also lacked the tools by which they could easily gather those workloads. So they had a lot of performance data, they had a lot of log data from their customers, but they didn't have a good way of being able to tie the pieces together. And the more we talked to customers about it, the more it became clear that the same issue existed within the enterprise side of things. And what they were looking for was a way in which they could share workloads, particularly when they're introducing new applications they may not be familiar with, they may not have all the environment stood up so they could study those workloads. Where could they go to get that insight and that knowledge? And the reality was, until we launched Workload Central, there really wasn't a capability out there. So Workload Central is a free service. You can upload your data. Your data is secure within the system. But if you create workloads, those workloads become public. And over time, one of the things we'll introduce is a concept of a private workload library, and I'll talk more about the workload library in a moment, where you'll be able to pay for a private workload library, whether you're a vendor or a large customer, sort of borrowing from sort of the GitHub model, if you're familiar with GitHub. So we're creating a community that allows them to share and analyze their workloads. I've been here all week visiting customers and really taking out the roadmap and vision for the new VI. And this service is...
Are people actually analysing each other's workloads, or are you analysing them for them? And then they're sharing them so that I could, for instance, see what my systems would run like with a workload that you happen to have already?
Yeah, it's the latter. So you can go in and analyse your data. The report on your data belongs to you.
Right.
You can create a workload based off those characteristics, so off the metadata about the data. Mm-hmm. And if you decide to create those workloads would then be public. But one of the things that customers have been excited about this week was the idea that I could go to Workload Central, I could publish it, but I could go and look up, well, I'm going to roll out Oracle 12G rack. Where can I get that workload? And oh, by the way, has it been run on an HP DL980? How did it perform? What was the configuration around that? So being able to tie not only the workload but the configuration around it, and sort of expanding that sort of concept. So I might sit down. It's a little easier to drive from the chair. But the first thing that we identified with Workload Central was the need sort of for education. So other than a home page that provides a bit of an overview of workloads and how to think about it, there is the workload library. And actually, let's see if we can.
So in this context, it's not the more general usage of the term workload, it's your specific usage of the term workload to refer to a set of information you can load into your system and replay against.
Yeah, that's correct. Where we're taking, so right now, where both companies are focused on is sort of really bridging the gap between applications and infrastructure and understanding how applications use infrastructure in the form of an I/O pattern and the characteristics around that. Where we will take it over time is a more holistic concept that spans not only the nature of the I/O between the applications and the infrastructure, but the resource pools used on both ends, so both the compute and storage resources. So being able to look at a holistic workload and make decisions about a workload placement across the entire infrastructure, rather than just the siloed approach that exists
Because that's
today.
what's going to get interesting. I mean, it's one thing to play an artificial load against an existing system, see how it performs, how many users do you have to load on before performance falls off and the system falls over. It's another thing to say, well, what if we had a system that was 4 times bigger, or different types of storage on the back, or whatever.
And that's actually the beauty of the way in which the workload model works, because it is a statistical model. It's very easy to stretch it or to shrink it and to look at those characteristics and do that sort of what-if analysis. But as we'll see as we see the data that we're looking at, you never just have one workload. So even if you're putting an Oracle workload, Oracle really is 6 to 8 separate workloads by the time you look at OLTP, logging, indexing, redo. They've all got discrete fingerprints associated with them that have very different characteristics. So understanding all of those and being able to break that apart and then recombine them to show this is what this individual component looks like, but this is what the entire infrastructure looks like. So the workload library is really at the heart of that. There are a range of different tags and different capabilities. We've got protocol workloads for those people who, and particularly the vendor community, who really want to be able to test particular command sequences and particular models for storage arrays, to more functional workloads, application-specific workloads and contributed workloads. So we could drill down on any of these and we'd see a set of different workloads, and I'll come back and describe this in a little more detail in a moment. But there are example workloads that we've provided based on the research and the work that we've done out there in the industry. There are the underlying models that can be used, and then there are the community workloads. So,
what does it mean, high fidelity?
Sorry?
There is high fidelity FC workload.
Oh, high fidelity.
Yeah, high fidelity.
Yeah, so good question. The high fidelity actually refers to the underlying model version that we're using. So we've been through a number of model evolutions, shall we say, and the high fidelity stands for exactly that. It's the hi-fi workload. It's the most accurate workload in the market. So the other aspect that we've seen, and really the workflow that Workload Central provides right now, get educated about your workloads, understand how to think about your workloads, the ability to upload your data, analyze your production workloads, be able to edit those workloads, and then download. And the download allows you to take that workload and run it in your load dynamics environment. Now, in many cases, we know customers probably may not get past the analysis piece where they're generating the reports and just understanding. And requests that we've had sort of this week was to sit there and say, well, can I just do a scheduled upload of my favorite workloads every week and then just do a baseline and a comparison between them, and you tell me when they start to differ. So we're already seeing a number of use cases that fit very nicely with what we're doing with Virtual Wisdom and the strategy around integrating those two capabilities. But from an education perspective, you'll see a lot more videos coming in this as we take this forward. But the number one question that we get is, love this data, how do I start? Where do I go to get the data? So we've spent a lot of time documenting for leading vendors, how do you go and get the workload data to understand what's going on? And then it walks you through every step of the process, as well as sort of describing the sorts of different protocols, how to use them, the sorts of use cases that you might use them for, and sort of really helping customers understand what a workload is, what do you do with it, and quite frankly, why should I care? So what we'll do, we'll just jump back here. I've already logged in as user 1, so I'll just go through, upload some data. And in this case, I've got an Oracle DB taken from an HDS tuning manager environment. I can add any number of tags, and I'm a fan of using Acme as my default demo environment. And the first thing that you'll see is that the data, and I can show you the data is just sort of a CSV file. But because of the structure of the data, the first thing that it's been able to do is identify the source of the data. So while I named the file Oracle Tuning Manager, it could have been anything, and it would have detected, based on the type of data it is, as to which array it's come from. I've got a range of out-of-the-box policies, and on the off chance if I didn't bring this up, I could easily request a new one. Now, in this case, I've actually got 4 Oracle policies. There is a specific policy that we'll use today because it allows me to show you different workload analysis and analytic capabilities and what that looks like together. But we could easily take that data, because in this case it's block data, it's SCSI data. We could create a fiber channel workload to replay in a fiber channel environment, or we could create an iSCSI workload all from the same SCSI environment. And what we're seeing from customers is a desire, particularly with the introduction of all-flash arrays, is to look at whether they continue on a fiber channel basis or whether they move to Ethernet. So being able to compare FC performance for the same workload to iSCSI performance is one of the things that customers are extremely excited about in terms of this capability. So we're not going to change that, we'll leave that where it is. There's a number of things I could configure if I wanted to, and that I could enrich, but in most cases there's no need to do that, so I'm not going to spend any time looking at that. And that'll import the data, it'll sort it, it'll create the metadata from it. While that's going on, I'll walk you through it. So this was a Virtual Wisdom data set. So someone uploaded their data straight from Virtual Wisdom. into Workload Central, we can sort of see a little bit about the data here. We could look at different anomalies if we wanted to, and we'd start to look at different trends. And we start to see the characteristics. So in this case, very low throughput and IOPS, but pretty interesting sort of behavior. So we can see the read-write mix, we can see the different request sizes. And in this case, the colors are always standardized. So green is always write, blue is always read, and we can see the different individual operations in terms of latency and other behavior. Depending on the data available, it'll populate a different range of charts. So while we've been looking at that, it's actually parsing through that file and building the graphs and things, and you'll see this gets more dense as more data points come on. And we can see that we've got some pretty interesting request size patterns and some fairly consistent difference between our read and our write. Now, if we were to look at the latency charts behind that, and we can see we've got some fairly spiky behavior. But the interesting thing for this one is the nature of the workload. Now, this is a set of workloads for an array. So this is looking at the entire array workload. So it's not just a single workload or other things. But the nature of this throughput suggests that there are multiple block sizes being used, which is off, just at the surface, indicating a different environment. So we could drill down and have a look at some of these characteristics, and we can see that there's definitely a different read and write block size going on. And it's still working through the analytics. One of the, aside from the visualization and the characterization that we've just been looking at, there's essentially a machine learning engine at the back that is going out and analyzing the I/O patterns, the block sizes, the behavior, along with the ITL paths and other things to understand what are discrete workloads. Including going down to sort of an offset level on the LUN if that's appropriate.
What's the other one from read and write?
Sorry? The other is all the other metadata commands. In this case it's a block workload, so it's the different SCSI commands, but for file workloads and things, metadata is a key reason that you'll see performance issues. So we finished the analytics. And this is actually the same one that I pulled in a little earlier. And you can see sort of the fuzziness of that environment. And in fact, we've got multiple workloads. Now in this case, I've set it up to look at workloads at different levels of granularity. So what it is able to do is you can specify how many workloads that you think should be on that particular environment. It will analyze it, but it will tell you what the quality is. So for example, in this case, we've created a situation where we thought there were 2 workloads, but in reality, the analytics are telling us that you could create 2 workloads, but the quality of that is only about 50%, which means you've got a lot more workloads in that environment. If we go to 4 workloads, we're at 93% in terms of quality. And once we get to 6 workloads, we're starting to see a 98% quality, which means that it's consistently seeing a range of patterns. And in this case, we could look at the LUNs, and we'd see that there were a bunch of archive LUNs in this case. If we look up here, we'd see that there were similar patterns, but because we've collapsed the workloads down to only 2 workloads, we're getting a whole lot of flash LUNs and other things coming in. So it's not really a good representation of the workload behavior. So from here, we could just click create a workload, and that would create a composite workload. So a composite workload creates essentially a set of workloads that can be run together. But you can tune each of the individual workloads and control the individual characteristics. And I'll come back and show that to you in a moment. But we'll step back to the data that we were just looking at. There are different types of workloads that the Workload Central is capable of creating. So there are essentially three main types. There's what we call a constant workload that basically takes a max or an average value and generates that as a flat line for sort of baseline testing. There is a temporal workload that actually mimics the IOP operation and IOP rate so that you get the same characteristics as the actual application workload exhibited. And that's what we call a temporal workload. So the IOPS are changing over time. It's a representative of time-based behavior and very critical to testing sort of business patterns over a period of day. Now you could collapse and take a slice out of any one of those environments. And now, with a click of a button, we've just created that workload. This workload is actually what we call a summary workload, and a summary workload is a baseline workload that encompasses all the traffic that we're seeing going to that array. So you can create discrete individual workloads that represent pattern, or you can sit there and say, I want to create a bunch of background noise that represents what the production load would normally look like, because then I want to go and do some what-if analysis around specific workloads and placements and deciding, where and how I should place those workloads. The key thing about this is as soon as we create the workload, we expose a whole lot of other knobs and things that you can tune. So in this case, we can specify the dedupability that we want to test for. One of the things that we find is, particularly in an all-flash world where the value proposition is heavily based on dedupe and compressibility, performance is equally tied to that element because there's such a significant load placed on the processors and all-flash arrays when you're running this, particularly at a maximum throughput. So being able to test and see what is the real sort of dedupe ratio that you can achieve for this workload and still achieve the service levels that you're aiming to achieve for. And likewise, we can create hotspots, we can drift those hotspots so you can test for sort of cold and hot data patterns. And separate that by having read and write hotspots. We can look at different load parameters and other things. So I just talked about a summary workload, but now I can drill down into any of the composite workloads. In this case, I can see what my dedupe ratio is, but I can select all of those if I want to and just scale that load. So I could take it by a percentage, or I could just scale it. And a concurrent worker is really the equivalent of an initiator or a host. So I can scale it up in terms of, go from 0 to 1,000% if I really wanted to, and see how that load would perform. So there's a range of sort of capabilities that I have in terms of being able to simulate and test different what-if scenarios. I can change the duration. In this case, it's actually 3 days that we were looking at. And all of these are things that I can do within Workload Central. So I can go and edit those characteristics. I can save that workload. And that would then publish to a library. So why don't we go do that?
So Tim, just while you're doing that, let's say I wouldn't speak, but do all of you get that this is a free web-based service that you can all use? The bit that you're looking at now, Workload Central.
I mean,
Just
presumably you have to have the tools necessary to generate the kind of files it can process.
So that's true, but it could be as simple as taking some IO-stat data off, a Linux host.
Could it? Oh, right.
The strength of the underlying engine is that it's not tied to any data type or data schema.
That's useful to know.
The biggest challenge that we find is people wanting to look at specific array performance, and that's why in the Get Educated section, there's how do I get my data from my Vmax, VNX, my VSP, how do I go and get the data? Because one of the things that we found that customers struggle is, well, we don't know how to even get that data out of the tools that we have. It's there. Can you help us?
Yeah.
So, we've spent a lot of time both with our customers and our vendors building up this sort of knowledge base to make it a lot easier for people to get access to this data. But right now we support that analysis at either the compute layer or the storage layer.
So, assuming the user can get the data out of whatever systems they've got, they can then go and analyse it for free on the system.
Correct.
And generate a workload which they could then replay using Blend Dynamics, for instance.
Exactly. And so this is the workload that we were just looking at. I could hit straight from that section the download, and in this case it would just generate a zip file that I could then import into my local load dynamics, and that gives us always a challenge trying to figure out where your cursor is when you've got this sort of split screen environment. Okay. So this is the Load Dynamics Enterprise product. You'll see it has some of the same sort of functions, so it's the ability to import data. But the critical thing that we want to show you is taking in that test, and in fact we've got that same test that's been running for a couple of days, because that piece of data that we analysed was actually a 3-day piece of data. So in the space of a couple of minutes we were able to analyse and characterise 3 days worth of array data. We can sit there and see that this is exactly the same workload that we were looking at before, now imported into Load Dynamics Enterprise. And Load Dynamics Enterprise actually has exactly the same sort of workload analysis capabilities built in. So you don't have to use Workload Central if you're already using Load Dynamics Enterprise in-house. But one of the things that we're seeing from our customers is the desire to push this capability out to a broader set of teams. So, for example, giving their application teams access to Workload Central as a free service, because the Load Dynamics Enterprise box is sitting in the lab that they may not necessarily want to give them access to their internal systems. But being able to enable them to do the modelling and the analysis, and then empowering the storage teams to actually do the validation of the infrastructure, rather than them trying to figure out, well, what applications out there, what does it look like, how do you think about this problem? So you'll see the same sort of set of capabilities, and actually if we just step back for a moment, so a couple of interesting things is that 6LUN you can see we've actually got it running in the background right now. But this is the composite workload that we just generated with a few differences. So we've allocated a test bed, and a test bed is the infrastructure template that you're running it against. So in this case, we're emulating an Oracle server, and it's running against 6 different services. So you've got an active redo, you've got, in this case, a semi-active redo, so a pair of redo. It's flash with small block sizes, flash with a constant block size. So we're actually simulating different characteristics of the overall service. And it's using MPIO, so it's distributing this across the entire infrastructure. Now you could turn off MPIO and see what that workload looked like from that perspective. One of the critical things in executing, workload simulation and things is what we call preconditioning. So actually pre-populating the array or the filer or the object store with data to actually run the workload against. So it's able to simulate, fill up the LUN to the right level, create a file tree with the right range of files from a distribution standpoint. So you can create a complete file distribution structure. You can create, a million files. And to give you an idea, we were doing some work with Isilon recently, and they were wanting to do a test and a validation where they wanted to run a cluster with 3 billion files on it of varying sizes and see, how did it perform when they changed sort of the classic end user scenario where you've got home directories and roving profiles and things, as well as throwing some Oracle databases on it. And so going everything from half terabyte database size to 40 meg profile, and sort of mixing up the different characteristics and the different elements. So being able to pre-configure an array to look like production is key to actually making it real, or as real as possible. So in this case, we're not running any pre-test, but we could quite easily do that. We could add more workloads in if we wanted to simulate a case of mixing our workloads. So if we were doing a workload consolidation, for example, you're reducing the number of frames, moving to an all-flash environment. So there's a number of different modeling sort of scenarios and capabilities that you have in that scenario, in this particular scenario. So once we actually start running the test, and as you can see, this has sort of been running for 2 days, we can start to look at a whole range of quality metrics for it, and we can look at just about any level of information that you like. In this case, we're looking at the latency histogram, but we could easily look at throughput versus command, for example. Throughput versus response times. So there's any number of analysis capabilities to help us understand the overall workload. And we quickly see whether it's actually able to meet the expectation that we have in terms of performance and placement. So we can see a range of different IOs attempted, failed, succeeded, etc. So this will continue running for a little while yet. So we'll just jump back up to the front. So in a matter of minutes, really, what we've been able to do is take the data, analyze the data, create a workload from it, upload that into Load Dynamics Enterprise, and hit the go button. Now, obviously, in a production environment, you'll take some more time to set up the infrastructure and other things. But in reality, what used to take many months if it was achieved at all, what we've been able to do is compress that into a period of time that makes this achievable and usable by storage teams today. When we first started doing this modeling capability in this data analysis, we used to send our professional services team out there, on an average it'd take them 6 to 8 weeks to do. We invested in, you know, sort of that modelling capability with the sliders and the ability to adjust that, and we got that down to days. But the biggest thing that we got from customers was, okay, it's great that you can make it easy, and in fact, I remember being at an EMC sort of event sort of 2 years ago where customers were getting really excited when they could see the sorts of permutations and things they could do. And the first question had been, well, that's great, but where do I go to get my workloads? And we've got services that can help you, and they'll do this, and they'll get the data, and they'll analyze it, and literally watch the blood drain from their face. You know, the excitement and things just disappeared.
So you're talking about hiring vendor services to come and do that workload evaluation and workload simulation?
That's where we were,
Yeah.
4 years ago.
Right, yeah. And by comparison now I can go and buy these tools to replace that vendor services engagement.
And in actual fact, you're not even having to buy services to do the majority of that work.
Yeah, so you can do it all yourself because most of the
It's very easy
most
to.
of the scut work is actually there on the website for you to
Exactly.
download and adapt. Yeah.
And it's free.
Do you use?
Well, it's free as long as I've got your assets.
Well, it's free if you want to recreate that workload in your lab. Oh, sorry.
Yeah.
Free if you just want to analyze it. If you
Yeah.
want to recreate it in the lab,
Yes.
obviously you've got to have the tools in the lab to do that.
Yeah, for some definition of free, yes.
Yeah. I mean, we're not completely altruistic in elements, but
Oh, and here I thought you were.
Is there a use? Sorry.
but I mean the reality is that
Yeah,
this
no,
is
I get,
there to enable the community.
I'm being a little bit snarky, I should be nice, but
No, you shouldn't, Greg. It's not your job.
Why do that?
Is there a usage of this in benchmarking?
Yes,
So
it gets used.
it's one of the biggest expenses of your hardware company. Rig up the thing and get it to run this benchmark. You could maybe run a common suite across different things more easily.
Yeah, so I mean, in terms of, this is more roadmap than it is where we are right now. But one of the reasons for doing this is going back to the comments I made right at the beginning when we had vendors approaching us for these benchmarks and things. I went and talked to my data science team and they said, sure, we've got 10 observations of that particular workload. We can give you something. Is it absolute? Do we know really whether that is consistent behaviour? Well, we know the behaviour for the 10 observations that we have. Building a community so that we can analyse, what is the variance, what is normal range of behaviour.
You see a system, you think, oh, that's great, it's got the best spec mark, and I understand spec mark, so I'm going to buy that system because it's obviously faster. Well, you've got the problem with time because the person to produce the product is usually the one, in the server market.
Yep.
But the other problem is, it does my workload. What's my workload going to look like on that, as opposed to this, highfalutin kind of simplified thing that they're running?
And that's exactly the problem with spec marks and things. And I had a conversation with a number of vendors because we get used to benchmark, in sort of bake-off type situations against different arrays all the time. And the customer was actually a customer here in the UK, had specified a constant workload, with very certain characteristics. And a number of the vendors in that went, well, that's not realistic. That doesn't. Well, and in this case, quite frankly, they had a case, but the point was, from that customer's perspective, every vendor was touting a particular approach that favoured, their infrastructure, and they said, well, we really don't care. We want something that's, that will level the playing field, that will allow us to evaluate. And this was prior to, this capability being available. And the problem was, they could argue, well, that behaviour isn't realistic and doesn't show the performance, and that was true. But at least it was some sort of benchmark that they could compare against. What they can do now is take what their actual production workloads and make that decision. Now, I talked about some of the services engagements and things that we'd done, and that's exactly what we found. So when we used to send our services guys in several weeks to do this, the customer would do this benchmarking exercise, and more often than not, we'd find that they'd choose multiple vendors and multiple products, because if you model a couple of different key workloads, you'll find that the different stacks and things are optimized for different conditions, and workload A may run well on array B, but not work so well on array A, and likewise workload B may run much better on array A than it did on array B. So we've seen a lot of those sorts of situations where at the time we got beaten up by the vendors involved because they were hoping to win the entire contract at that point. 18 months on, they recognised that that it would actually cause them a lot of pain because their solution was not optimised for the nature of that particular workload, and they'd had far less problems with the customer by taking the piece of business that really met the need. So part of this and part of Workload Central is not only to enable benchmarking, but it's to help vendors and customers really come together around workloads and common workloads, because we find when you've got a realistic workload and you've got a performance problem, particularly if it's something specific to the array and you take that back in the lab, the time to finding the issue reduces significantly. And we've seen this constantly in POCs, where they've had issues that have been ongoing for a period of time. The workload goes back to the vendor and the vendor's able to find and recreate the issue and solve it in days.
So I have a question here. It could be a bit a stupid question actually, but I can figure out. So now we have all these virtualized workloads, right? Tons and tons of virtual machines running on disparate servers and storage underneath. And it's becoming quite complex to manage all of this. So tools like storage ideas, storage. The tool that VMware uses to move the things.
Oh, DRS.
DRS, yeah, okay. So.
Yeah. vMotion within DRS.
Yeah.
Yeah.
So they are, and it's becoming complicated because you have the arrays that now are much more smarter than in the past. They have the VSA, VASA provider, so that on top you have some intelligence that can leverage that information, move things around. So also doing benchmark becomes really, really hard. So I don't know if your solution is still effective in this case.
So that's a good question, and I'll flip that round a little bit and say, well, if you're able to emulate the workload and the workload characteristics in a very realistic way, then you're able to tune and optimize that infrastructure. So if you've got a set of workloads that you're running against your VASA and VAI enabled arrays and things, you're going to create a situation that is exactly what you see in production. So if your infrastructure is not keeping up or adapting in the lab, what are the chances that it's actually going to be effective in production? And one of the I've spent the last 2 weeks basically taking our vision and our roadmap to the combined customer base. So I've probably seen 50 customers in the last month, something in that sort of range, and I'm seeing some interesting things, and that is that they turn off more of those features than they use because they can't provide predictable behaviour around it. And I'm seeing it not only at the VMware level. How many people actually allow vMotion to dynamically move workloads? In some cases, it's a small portion of their entire real estate because they can't deliver predictable service levels. So The point that I'm making is this allows you to at least understand that behaviour and tune for that behaviour. It's not going to necessarily solve for the complexity that introduces, but it gives you predictability in terms of how that will behave. And being then able to take that and say, well, okay, this is what this workload looks like on top of the VASA infrastructure, but what if I dial that up? What if I add new workloads into that environment? How will that compute handle? Will we see sort of VM thrashing because we're moving VMs across the board? And quite frankly, from a virtual wisdom perspective, what you'll see from us is, we've got VM placement analytics today that look at where is the ideal place to put those VMs based on their I/O requirements as well as their compute requirements, to be able to inform things like DRS to make better placement decisions, because DRS is fairly dumb in terms of what it does from a compute layer. The fact that it can trigger the move is pretty cool, but the number of metrics that feed that decision are fairly limited. So you're not going to get optimal placement because it's designed to support availability, not performance necessarily. So from a virtual wisdom perspective, we've been focused on adding more of the performance dimension that's not just compute performance, but also the I/O performance as well, ensuring the throughput. I know, looking at your face, I can see that you don't feel like I've answered the question, but yeah.
No, there are some. So I understand. So it's not all use cases, okay? So probably if you are really performance driven or consistency driven, then I agree with you. So you in any case, you bring a benefit because you have the right kind of customer to look at the section. On average, is difficult because most of the workloads are good enough is if they are in the range of latency so in a range of latency, not the exact latency.
I mean, if they're a workload that is not where performance isn't one of the criteria, so you're not concerned about latency and other things, then you might be concerned about other capacity metrics and things where this can help. But performance becomes less important. And I mean, a classic one in that case is a lot of the object use cases that we see in terms of archiving and backup. It's then not about what is the latency to do sort of large objects in terms of backup, but it does become how many concurrent sessions can you support, how much throughput can you support with that same infrastructure. So you can use the same approaches to look at the capacity and the scale issues that you face in moving to that.
So you're saying there, if I went from say 50 to 100 VMs, how much backup load would I create?
Correct.
I could simulate that backup load.
Yeah.
And cause it to happen across the storage.
Yeah. And in fact, these same things get used to drive sort of DR behaviour and synchronous behaviour across data centres as well for exactly the.
Because I was doing I was building a public cloud, and we were trying to work out what would happen if we went from 1,000 to 2,000 VMs in 2 weeks.
Yeah.
And then all of a sudden we tweaked to the fact that we needed not only to have twice as many servers and twice as much storage, but also twice as much backup. But we couldn't find a backup solution that could increase that fast.
And probably 4 times the bandwidth.
Yes, etc., etc. I wanted to ask about your probes. I haven't looked at your physical packaging, but this brochure suggests that there's a hardware platform, which is your management engine.
Mm-hmm.
There's a box for that, and then there's a box for the fibre channel part. I'm working with customers who think fibre channel is a pretty funny joke, and would rather we have automated setups of the testing labs. So the actual deployment of all the tools and the testing tools is all done as part of like in a Docker container or a VM, and it's all automated.
Yep.
Can I deploy your Wisdom management platform as an automated thing? Does it run in a VM?
It does run in a VM.
Yeah.
So on both sides of the family, we have VM versions and we have appliance-based versions. Quite frankly, the reason for the appliance-based versions is not because the software is bound to the platform. it solves the go-to-market problem of we've then got to go procure a set of servers to run this on.
Yeah, no, I understand that part of it.
And
There's a certain type of
that's all
customer-
that is.
Yeah, there's a certain type of customer who can't. If you're a storage person, you're not allowed to buy a server.
Yeah.
Yeah. So if I buy your storage appliance, that's not a server. Right.
Yep.
The second part is your network probes. You're talking about network switch probes. Are you literally taking a tap for a span port off the Ethernet?
So there's really two types of network probes. There's the ones that are actually listening to the network traffic, and then there are the ones that are probing the network switches themselves.
No.
So the network switch is a software-based probe. The hardware-based probe is looking at all data in line rate and doing the analysis at line rate. There's not a software solution that can keep up with 24 full duplex lines of 16 gig today. The only place you can do that is in hardware, and in actual fact, the solution underneath it is, we've got our own FPGA capabilities that we're doing to do that level of processing.
Yeah. There's some interesting things going on. You can start to do Docker containers inside switch operating systems, which can get close, actually. You just might have to do an unloaded, you might not be able to use all 48 ports, or you might only be able to use 12 for testing or something, but you can get close to that.
Yeah, we're looking at some of those sorts of items. So, going back to the question around DRS, you start putting a container layer on top of a virtualized layer.
Yes.
The blender effect that you had before just got that much worse, and trying to unload it. And the only place to really be able to determine some of those discrete patterns is to unwind it before the hypervisor gets to it and blends it. So being able to tap the container layer, it will become increasingly important. But it's like in the same way with OpenStack, if you look at Open vSwitch or any of those sorts of technologies that are contained in it, they have a concept of a VTAP. The problem with all of these sorts of things is, it's doing it in band has a certain cost associated with it. So
Yeah, you'll see with Docker it's a little easier because I can fire up Kubernetes and I can spawn 1,000 or 10,000 Docker containers and run my own load testing against large infrastructure. I don't need to simulate the load outside of the band, if you know what I'm saying. The trick with storage arrays is to be able to generating a load on the is monitoring the performance of the storage array, right? So you have a specific value there. But for containers, I can spin up an automated load and test it quite simply because I have all the tools. So I would need to be a little more convinced of that value prop.
Yeah, that's an interesting question, because if you look at sort of the application load testing and things that you're going to do on that, spinning up large numbers of container instances where you're running exactly the same workload with exactly the same behavior is a pretty significant management challenge in itself. I mean, there are companies like Zoasta out there that have solved that problem, but it's taken them 10 years to do it.
Oh no, not with Docker. It's trivial in Kubernetes to run up 1,000 different workloads for 10,000 containers.
Well,
it's
it's pretty trivial to deploy that, but to drive those workloads, that's where the complexity is what I'm saying. It's not, the complexity is not in the scaling at that point. The complexity is in the running the workloads and compiling the results and things like that. So if you look at what we do with the appliance, it can simulate 1 million IOPS per port.
Yeah.
It can do 1 million clients or more per port. So you think about the containers where it's able to already simulate the effect of 1 million containers just on a single port. So then it's not about whether you can deploy it, it's whether you can aggregate and pull all that data together to say, well, what is the result for those 1 million containers? So that's where the value comes in that space.
I've been talking to people who run 80,000 servers in a data center, and they have just a team of 2 or 3 people running up these sorts of tests, but they do end to end. And they do not just the creation, but also the monitoring. reporting, so it doesn't take a whole lot of resources.
Mm.
I was just sort of trying to get a map of how that worked out
Mm.
together. But yeah, having the virtual appliances makes it easier because we're more likely to click and deploy virtual testing platforms as part of a package and then pull it back out and then wipe the lab clean and start again
Yeah.
for the next run, rather than have, hardware appliances lying around.
Yeah, I mean, the reason people choose the hardware appliances is just sheer density they get. It's really difficult to run many of these platforms at line rate. If you look at just an Ethernet appliance, in an 8-port configuration, that's generating 160 or close to 160 gigs worth of traffic, and that was where Load Dynamics originally first differentiated themselves, because you won't get that out of any Linux stack. The stack that Load Dynamics has was written from the ground up, so that it was highly tunable and highly scalable and highly configurable, because the average Linux or Windows TCP/IP stack is lucky if it exceeds about 60% of the total capacity, because it's doing so many other things. So, people choose the appliance because, quite frankly, it's more cost effective than running up a bunch of infrastructure to support it.
As I said, there's some people who love it.
Yeah.
But some of the early stage adopters of the next phase, I'm just trying to understand how it would bridge both.
Yeah.
I guess.
No, and it's a fair question. Look, we've got some of our vendor customers that have, mandated, sort of UCS infrastructure across that, and they can't put anything else in there, and they're a completely virtualized fabric, and that's what they run, and dial things up and down. They don't get anywhere near the performance from the resource consumption is higher than it would have been from an appliance.
But still cheaper, and it's more flexible. And a wider
Well, they've
range of
made a
possible-
decision at a data center level rather than the lab.
Yeah, that's right.
So, if you were making that decision at a lab, then the difference having one server versus 20 servers you might care about. In a data center where you've, to your point, they've got 2,000 servers that they're just wiping clean.
Yes.
And then deploying whatever software infrastructure they want over the top. It doesn't make sense at that sort of scale for them because they've already made that investment
Yes.
to use it in more of a utility model. So, we see both.
Yes.
So I'm happy to talk about sort of any of the other capabilities that we have. There's a full analytics platform here. You can look at any of the data sets. And one of the cool things about it is with the reporting and analytics, you can take any of the test runs done in Load Dynamics Enterprise and compare it against any other. So if you want to compare what the results look like for the same infrastructure for last year versus the changes you're planning for this year, you can baseline them against each other and see what the performance differences and things are. Just a very wide range of capabilities. And the reason that those capabilities exist is to support the regression use case, to ensure that as you introduce new applications and things, that you're seeing consistent performance from the last major release cycle and things. But otherwise, if there aren't any questions, I pretty much covered what I planned to cover today. So,
Congratulations on merging the two companies together.
thank you.
That's a feature. It's not a bug.
From that perspective, because I have roughly half the organisation reporting into me, I couldn't be happier with the way the teams have embraced each other. The engineering teams were highly complementary. Load Dynamics started in the Ethernet world, and VI was obviously best in class in the fibre channel monitoring side of the world. So we're already seeing both sides cross-pollinate. So you'll see a NAS probe come out from us in the autumn timeframe, where it's already leveraging some of the expertise from the LDX folks to accelerate some of the things that had been worked on the virtual wisdom side of the family. And likewise, we're already seeing sort of some data analysis techniques come the other way around. So it's been fun. And we've also been able to grow the team sort of 20% since we brought the companies together. So we're on a pretty good trajectory right now, and customers are responding extremely well to the road trip that I've been doing, taking out the vision and the roadmap and the strategy that we have. So thank you for your time today.